Hey everybody, hope your day's going well. I decided to make a couple of videos with some examples of how you can factor complex trinomials, just because it wasn't really clear, whether or not we were going to be able to meet in person today for this lesson, or if maybe we were going to have to be online. So I thought, let's film it, and then you'll have this as a resource, even if you want to refer back to it later. So in this lesson, our success criteria is going to be whether or not you can factor polynomial expressions of the form ax squared plus bx plus c when a is not 1. So we've done simple trinomials before, now we're looking at complex trinomials. By definition, a complex trinomial is one of this form, ax squared plus bx plus c, where a is not 1. So whereas in previous days, all the trinomials that we had seen had looked like this. Now there's going to be some number that is not 1 in front of this x squared, and that by definition makes the trinomial complex. So let's look at an example of how you can factor these types of trinomials, and I'm going to model for you two strategies that you could use to be able to factor these types of trinomials. We'll do one in black marker and then one in red so you can differentiate the two. So the first strategy that I'll model for everybody is called the AC method plus grouping. And it's called this because it involves and pretty heavily relies on factoring by grouping. So if you really like doing that and you think that that's very easy for you, this might be the strategy that you prefer. So in order to do the AC method by grouping, the first thing that you do is identify the a, b, and c values in the trinomial. So for 2x squared, that means that 2 is going to be the a value. So we get 2 for a. The b value is going to be 7. And then the c value is going to be 6. So for the AC method, this is just like what we were doing with the simple trinomials, where I'm just going to kind of create our little cross or baseball diamond here. And you're going to have to figure out two numbers that when you multiply them together will give you a product equal to a times c. And then two numbers, those same two numbers, when you add them together, have to give you the b value. So in this case, we're looking for two numbers that when you multiply them will give you 12, and then when you add them together will give you 7. So this is why we spent a lot of time on the mental math with the simple trinomials. As a refresher, if you want to know what are the possible numbers that you might add together, just start listing factor pairs for whatever the number is for a times c. So in 12, those numbers that could multiply to give you 12 could be 1 and 12, or 2 and 6, or 3 and 4. If I were to change the order of this, that's all we would be doing. So that there are not more factors here. So then you would look at the factor pairs that you create and think, all right, do any of these add to 7? Well, this one does. 3 and 4. If you add 3 and 4 together, they're going to give you 7. It didn't matter what order I wrote those two numbers in this diamond. Remember that. It doesn't matter what, if I could have written 3 here and 4 here, it would not have made a difference. I just wrote them in that order because that seemed logical. You don't have to. So don't let that part confuse you, the way that I wrote the numbers, all right? Once you have this, then the next part of this strategy relies on breaking apart the term in the middle. So we're used to collect like terms, now we're uncollecting them. We're like breaking it apart. So for 7x, I'm going to rewrite the expression. We'll have 2x squared. 7x can be broken down into 4x and 3x, right? And notice how if we were to add those together and collect like terms, you get 7x. This is where the grouping is going to come into play. So this expression is equivalent to 2x squared plus 4x plus 3x plus 6. Right? Once you arrive at this step, your next goal here is to make your two chunks that we're going to use to factor by grouping, which we've also done earlier in the unit. So I'm just grouping them based on what are some common factors that emerge to my eye. So I know there's going to be a common factor between 2x squared and 4x, and there should also be a common factor between the 3x and the 6. So now, in terms of common factoring, that was also earlier in the unit, and I don't want to spend too much time explaining how we would actually pull out common factors. That's a different video. That would be a different lesson. We have to figure out the common factor between 2x squared and 4x, which is going to be 2x. And then to figure out what terms go in the new set of brackets we're creating, we have to divide each of the original terms by this greatest common factor. So 2x squared divided by 2x is going to give you x. If you're confused about how we got that value, consider reviewing the exponential expressions lesson and how we simplified exponential expressions. So we'll have x for this. 2x squared divided by 2x equals x. And then 4x divided by 2x is going to be 2. So we'll get 2x times x plus 2. That's the factored version of this first chunk. Now we have to find a common factor between 3x plus 6, 3x, and positive 6. So the common factor there is going to be 3. And then 3x divided by 3 will give you x. And then 6 divided by 3 will give you 2. So now you'll probably notice that this looks a lot like a binomial common factoring problem that we've also seen earlier in the unit. So to rewrite this expression as two sets of binomials that can be multiplied, the first one is just going to be this set of brackets that's common, so you'll get x plus 2. And the other set of brackets is going to be based on what is left over. So there's the 2x, and then there's also the 3, so 2x plus 3, that's our other binomial factor here. And then this would be the final answer. X plus 2 times 2x plus 3. So this would be the fully factored version of 2x squared plus 7x plus 6. And we figured this one out using the AC method plus grouping. So AC just comes from the fact that you have to multiply A and C to figure out what your middle terms are. And then you have to factor by grouping to get the final answer. So if you don't like that strategy, or you're not sure about it yet, I'm going to model for you another way that you can solve these types of problems. But my warning to you is that this strategy is not really very mathematical, and it might not always work. It usually will, but there are some additional rules that you would have to memorize if this second way is going to be your preferred strategy. So this other strategy is called slide and divide. And as we work through this one, you'll see that we actually have no right to write an equals sign down the solution like we did over here. This way is the standard way that most people would factor complex trinomials, and most textbooks would show you how to do it, and most videos online would explain it. This is just another way that you can possibly use. So for slide and divide, we'll rewrite the complex trinomial, and then the a value here, so in this case it's 2, we slide the a value over to the last term with c, and we're multiplying the a value times the c value. So multiply 2 times 6. And you're going to rewrite an expression now, x squared plus 7x plus 12. So this method relies on us creating a simple trinomial to start with, which technically we can do because we haven't actually changed the product of a and c, right? 1 times 12 and 2 times 6 both give you 12. So once you have this simple trinomial, then it's just a matter of looking at what are the two numbers that would add together to give you 7 and multiply to give you 12, which we already figured out. So this part here is going to be common to both strategies, regardless of the one that you choose, which is why we had to do a lot of that sum and product table in class earlier in the unit. So since we have 4 and we have 3, the next step is to rewrite this simple trinomial we made, where these appear as integers, so x plus 4 and x plus 3. So this is basically just like factoring a simple trinomial that we had already done. And then, once you have this, here's where the kind of sliding, dividing part comes in. Since the a value equals 2, and it had previously just disappeared, we're now going to divide each of these integer terms by that number. So divide 4 by 2 and divide 3 by 2. And then wherever possible, if you're using this strategy, you need to simplify fractions into whole numbers if that can be done. So this means that because 4 divided by 2 is 2, we're going to have x plus 2 multiplied by x plus 3 halves. And then the sliding we did at the top, you're going to undo that. So this 2 is now going to remove itself from the denominator in this part here, 3 halves, and is going to be multiplied by the x. So this will become x plus 2 times 2x plus 3. So this still gets you the same final answer. I would accept this like on a quiz or test if you're looking for a different strategy. But again, this is not a very mathematical way to solve it. It relies a lot on number tricks. So you'll still get the answer doing it this way, but this is the formal way that actually shows why the math works. This is just another strategy that you can use if this one's giving you a little bit of trouble. Regardless of the method you choose, we're going to get x plus 2 times 2x plus 3 as your final answer.